Right, so the section we're doing is 2.6 on properties, properties of congruence and of equality. And I do have this typed out if you want it typed. If you would rather have it in your own handwriting, that might be an easier way to keep track of it, especially if you have a spiral notebook. If you are doing 3-ring binder, it's easy to put this in there and keep a hold of. So who wants a typed one? In this room? Right, we're doing some properties. They're called reflexive, symmetric, and transitive are the first properties that we're going to do. Reflexive property is simply stated as an expression is equal or congruent to itself. We're going to put some examples of each property up there. Grab my notes so that I'm sure that I get an appropriate example. Okay, we'll do an example with the equal sign, and we'll do an example with the congruence. Okay, you can have segments or angles. We're going to make an example for each one. In equality for segments, we would be saying like AB equals AB. What does AB mean when there's no symbol up on top of it? Distance. So the distance from A to B is equal to the distance from A to B. Something equal to itself. If you stated that with angles, it would say the measure of angle ABC is equal to the measure of angle ABC. That's how it would look if it were stated with angles. Or it might be angle 1 is equal to angle 1. Angle 2 is equal to angle 2. If it's congruences, segment AB is congruent to segment AB. You have the segment symbol when you're doing congruence because you're naming the actual object. How would it look like if it were a congruence involving angles? ABC is congruent to angle ABC. There's no M because it's not the measures that are congruent, it's the actual things. Okay, so the measures are equal, the things are congruent. So as you look at each of those, does it do what it said? An expression is equal or congruent to itself. So it's the very same thing on both sides. That's what the reflexive property is. Doesn't maybe seem like that's very useful, but it is, depending upon what we need to do with it. Symmetric property is a little bit more involved. Okay, symmetric property says the expressions on the two sides of the equality or congruence symbol can be interchanged. What's interchanged? Interchange things. Let me switch to around. Okay, instead of AB, then it's BA, that kind of thing. Okay, so we're going to say how it is to begin with. If AB equals CD, then interchange the two sides. CD is equal to AB. Correct. That's supported by the symmetric property. If measure of angle A equals measure of angle B, then how would it appear when it switches the two sides? Measure of angle B equals measure of angle A. Congruences. If segment LP is congruent to segment XY, then
segment XY is congruent to segment LP.
Segment XY is congruent to segment LP. If angle 1 is congruent to angle 2. Then angle 2 is congruent to angle 1. So on the symmetric, you have to see the statement first, and then you can switch the two sides of it to come up with the related statement. That's called the symmetric property. Could be the symmetric property of equality, could be the symmetric property of congruence. So there is, you have to do, or you have to specify which one it is. Does it have equal signs? Does it have congruent signs? Those of you that are writing the whole thing, are you keeping up? Let them finish writing. And you can make up your own examples. They don't have to be the very same ones that I have, but they would have to be created in the same way. A transitive involves 3 equations. So you see 3 blanks for each example on the transitive. There are 2 statements that we'll have in the if part, and then we'll put those together in a certain way to come up with the statements for the then part. Okay, transitive. Through a chain of equations or congruences, you can get expressions equal or congruent that were not known before. Order is important in the chain. We need to have the right-hand side of one of the equations repeat as the left-hand side of another one so that they hook together, so they link together, kind of like the cars of a train. Transitive, train idea. Let's start building one. If AB equals CD, and CD, that's the part that has to repeat, equals MP, then you can put these together, leaving out the one that repeats. That just hooks them together, and we don't state it again. So we will get then AB equals MP. So take a look at how that one's created. See the CD repeating? The right-hand side and the left-hand side of their equations. That's the link that hooks them together and drops out. You get the first and the last. Kind of like syllogism, those if-thens that we were linking together. Okay, what would an angle example look like? If the measure of angle A equals measure of angle B, and what do I need to start the next one with?
Measure B.
Good. Measure of angle B equals measure of angle C. Then
Measure of A equals measure B.
Yep. Measure of angle A equals measure of angle B. Or, excuse me, C. Measure of angle A equals measure of angle C. Congruence examples. One with segments. Shay, start us off. If what segment's congruent to what segment? DE. Okay, Cody, take it from there. And she gave me like this part, and you have to create this part. It has to start a certain way. Okay, and segment DE, segment, make it up, what do you want? GF. See how hard it is being a teacher? You have to decide things like that. Then, now this has to be correct. Fill it in. Natasha? Can you use the idea that we were showing up here? Do it with what they've set up. I'll put that here. Yeah, AB is going to be the first one. Then segment AB is congruent to segment GF. Okay, the bottom blanks are for angles. Yeah. Start us out. Jaden, give me two angles that are congruent. What do you want to call them? Angle A is congruent to angle B. Okay, and Sam, do you know what you could do for the second part? Congruent to angle K, you said? All right. Put those together, Allie. What do we come up with? Angle A will be congruent to angle K. Question on those? How to plug your notes? All right, before we look at the ones that are on the back, we'll do some practice on these. All right. I have a worksheet here that has a few for you to match up. Okay, this has a statement and then names of properties you're matching. And there's another, down here it's not matching, it's fill in to illustrate the sample, 3-hole punch. And again, we're just doing the front side. Then we'll go on to discuss things related to the back side. Look at the statement, angle B congruent to angle B. Is that a reflexive, symmetric, or transitive? Is it of congruence or equality? What kind of things are congruent? It's like an angle is congruent to itself. You might not find the very same example as what is on here in your notes already. Look for something that's set up in the same way. Just the front side right now. Okay, since you have new seats, you should have a new partner. Front row and second row, you'll match up or pair up today. And then third row pairs with the fourth row. You'll just either go with that group or the one in front of you. All right, so discuss your answers on the front side with your partner. As far as you got.
Wait, what did you get for three?
Do you see why these are
Yeah.
Switching the sides.
I did too with the equal.
All right, let me go through what the answers are so that making sure that you didn't both miss it. The first part was DEC FAB. Discussion on some of those top ones. Okay, bottom ones. Number 1 should have said measure of angle A. Number 2, GH equals EF. Number 3, measure of angle 1 equals measure of angle 3. Number 4 should say segment KL. 5 should be angle 6 congruent to angle 5. And number 6 is segment AB congruent to segment EF. Okay, I have a feeling I should write a few more examples up here for you to do. So grab your marker board. We'll make up a few more before we look at those last properties. They all make up a statement, and you tell me which property it is. What property is that, and is it of congruence or of equality? I'll ask you to show me all at the same time so I can check. Good job. Symmetric property of congruence. How about, x equals x? Show me. Reflexive property of equality. Very good. If measure of angle MPL is equal to measure of angle XYZ, then measure of angle XYZ equals measure of angle MPL. On the board. Show me that one. Okay, got some of the mistakes on this one. It is symmetric property of equality. Maybe you were expecting transitive, because I haven't done one of those yet, but nope, it wasn't transitive. It didn't have enough things in the if then. If it's a transitive, it's going to look like if angle XYZ is congruent to angle MPL and angle MPL is congruent to angle RST, then angle, what would be my transitive statement? What would it say up here to finish correctly on transitive? Morgan? That would be an example of transitive. Notice how it's got two statements in the hypothesis. Transitive has to have those two statements to put together. All right, we better cover the other properties. So let's grab your notes again. The last, I think, 5 properties. The first 3 of them are computation. Are you adding on each side of the equation, or subtracting, or multiplying, dividing? So these will be used in solving equations a lot. So the addition property, and it's the back side of that note sheet I gave you if you're using it. Adding the same number to each side of an equation produces an equivalent equation. What's equivalent equation mean? An equation that has the same solution. So you did addition property of equality in Algebra 1 when you were given a problem like solve x minus 9 equals 16. What do you do to solve that? Okay, Kenna? What do you do to solve this one? To one side?
16.
Plus 9. Aren't you actually adding 9 over here also? So what you're doing is adding 9 to each side of an equation. That's what the property says you can do. Adding the same amount to each side of an equation produces an equivalent equation. An equation that's still equal has the same solution. Those of you writing, you're going to have to write quick. Or else take the sheet and then write it in your own notes. Subtraction property, subtracting the same number from each side of an equation produces an equivalent equation. So you can subtract the same amount on either side. So if this were your example, solve x plus 7 equals 30, what would you subtract from each side?
7.
7. Subtract 7 here, subtract 7 here. You get x equals 23. You did the subtraction property of equality. There's a multiplication and a division. I'm going to give this people that are writing the notes the sheet just in case you can't keep up. You'll have it to write. The multiplication property of equality. Multiplying each side of an equation by the same non-zero number produces an equivalent equation. So if we were solving, we've got 1/3 x equals 12. What would you multiply each side by to solve that?
3.
3 or 3 over 1? Right. Multiply by 3 or 3 over 1 on each side. And that gives us x equals 36. And the fourth one is division property of equality. Dividing each side of an equation by the same non-zero number produces an equivalent equation. So we would divide by 5, divide by 5. You're going to be solving some equations and showing what property, or saying which property you're doing at each step. So nothing different than what you did solving in algebra. We're just going to, in addition, write down what the name of the property is. And there's also a substitution property of equality. Substitution property. Substituting a number for a variable in an equation produces an equivalent equation. That's the way that you used it in algebra. The problem might have said evaluate 5x plus 7 when x equals 3. So what you did was substitute it in. So you put the 3 in for the x. 5 times 3 plus 7. That's really all substitution is just putting it in there. Now we would probably multiply and add 7 in order to finish it. Now I got the hiccups. Somebody gave those to me. So substitute is just replacing it, and then we would probably calculate. Okay, so now go to that samples sheet. On the back side of that has some problems for us to solve, and we're supposed to give the name of the property used at each step. All right, let's do the first one together. First one has 5x plus 10 equals 40. Did I write given?
Yes.
Yes, okay, that's what's given. Now, when you do this from your textbook, you're going to need to write that equation as the first line in your step-by-step. So you've got to get the given equation on your paper. Then what would we do to solve it?
Subtract 10 from each side.
Okay, subtract 10 from each side, which gives us 5x equals 30. What property did we use? Okay, subtraction property of equality. Then what? What would we do next in solving? Okay, you're going to divide each side by 5. So that gives us x equals 6. And what we did was division property of equality. You can do some abbreviating. On subtraction, don't abbreviate with SUB. Because SUB could be substitution or it could be subtraction. So you have to go longer. If you were abbreviating subtraction, SUBTR would tell me subtraction, SUBST would indicate substitution. Okay, question on that problem. Okay, do the next one. Number 2. x over 4 plus 12 equals negative 20. That was the given equation. Suggestion for a step to do.
Subtract 12 from each side.
Subtract 12 from each side. X over 4 equals negative 32. I did the subtraction property of equality. What will we do next?
Times each side by 4.
Would you agree with her? Multiply by 4 on each side? Correct. Multiply by 4. And that's going to give us x equals negative 128. And we did the multiplication property of equality. You see you're doing just your algebra and then writing the property on each line. I'm not writing the property where I'm showing my work. I'm writing it after I've written, this is what I get, and what I did was the subtraction property. Why don't you try 3 and 4? Do your step by step. Put the property beside each line. Substitution or subtraction? Show me step by step. Problem 3 could have more than one solution to it. Okay, Dallas, what'd you do for your first step on number 3? Okay. So if you did something different, that's possibly fine. Let's see how it ends up in the end. He's got 36 plus x. He did the addition property of equality, then what would Dallas do? What did you do next? Okay, do what with the x?
Subtract x from both sides.
Okay, so 2x equals 36, that was subtraction, property of equality. And then he's going to
Divide each side by 2.
divide each side by 2. And get x equals 18, division property of equality. Now, if you did some things in a different order, but you still ended up with x equals 18, you could have a correct solution, just a different process. At the end, if it had come up with 18 equals x, I want you to switch it to make x equals 18. If you have to do that, what allows you to switch it? Symmetric property. If 18 equals x, then x equals 18, symmetric property would do that. And problem 4 probably did an addition property of equality, and then a multiplication property of equality. X was 300 if you did it right. Right, the bottom two just have a substitution step. So we'll do 5 as an example, and then have you do 6. So on number 5, you've got 6x plus m equals 57 that was given. Okay, first thing we're going to do is substitution property of equality. What can we substitute? Well, it said let m equals 15. So you would get
6x plus 15 is 57.
okay, that's the substitution step. Then start doing the solving. So you'd probably do now a subtraction property of equality. So you would get 6x equals 42. And then probably a division property of equality. Divide by 6. So x equals 7. So that one, once we did the substitution, was no different than the earlier problems. So you do number 6 while I'm writing your assignment up on the board here. You're given an equation on 6. Your first step should be the substitution property. And then do your solving steps after that. Number 6 done? Substitution property, then what property? Not division.
Addition.
Addition, and then division. So the given, the substitution, addition, and division. X was -2. All right, out of the book, the first ones are like naming, is it the reflexive, symmetric, transitive property? Then there are some to solve. In the back of the book, I'm giving you some problems back there. I want you to solve it like what we were doing here. Give the property and show each step in the solving. So that part is important, not just coming up with what the x equals, but support each step. You've got time to get started on that.